Hello, my dear students. Today we are going to discuss Pandas series data structure. Before moving to series data structure in detail, we will have an intro to Pandas. Pandas stands for Panel Data System. It is the Python's library for data analysis. Data analysis means it's the process of evaluating big data using analytical and statistical tools. And the author for Pandas is Wes McKinney. What are the significance of Pandas? It's an open source BSD library built for Python programming language. Open source means free of cost. You can download it freely. The source code is also available. You can modify the source code. Even you can redistribute it. BSD full form is Berkeley Software Distribution, and it's a Unix operating system derivative. And also Pandas provide data structures and functions for data manipulation as well as analysis. It provides fast and flexible data structures. It is capable of handling bulk amounts of data, and it has multiple ways to handle missing data. How to use Pandas? To work with Pandas, it is necessary to import the Pandas library to the Python environment you are working on. For that, the syntax is import Pandas as PD, where PD is the alias name for the Pandas library. And you can use, instead of PD, you can use any valid identifier name. So what are the valid identifier naming rules? You can use any alphabet, both uppercase or lowercase letters. You can use numbers and the special character underscore. You can start with an alphabet or underscore, but you should not start with a number. The only special character allowed is underscore. You cannot use the keywords or the reserved words. And the Python variable or the identifier names are case sensitive. How to take care of these things while naming the identifier. And we will see how can we install the Pandas. Pandas library is pre-installed with the Anaconda distribution, so you don't have to install it separately. But if you're using the ideal Python, it has to be installed separately. And how can we install? You have to use the command, following command in the command prompt, that is pip install pandas. Pandas sum function return the result in the form of NumPy arrays. NumPy arrays means NumPy full form is numerical Python. It's an array that contains the values of the same or homogeneous data type. In order to use the NumPy array, similar to the Pandas library, you have to import the NumPy module to our Python environment, that is using the statement import NumPy as NP, where NP is the valid identifier name or alias name for the NumPy. And if you are using Python ideally similar to the Pandas library, it has to be pip install using the statement pip install NumPy. Moving to Pandas data structure, Pandas offers various data structures, and among that the three basic data structures are series, which deal with one-dimensional data, a data frame, which deals with two-dimensional data, and panel, which deals with three-dimensional data. But as per your syllabus, you have to study only series and data frame data structures. Rather than that, Python provides another data structures like arrays for storing and homogeneous data, stack for storing LIFO model data structure, then Q4 like FIFO model, first in, first out. LIFO stands for last in, first out. Okay, now moving on to the Pandas data structure. Today we are going to discuss series data structure in detail. Series data structure represents a one-dimensional array of indexed data. Okay, and a series data type is having two objects, that is two main components, an array of actual data, okay, and also an associated array of indexes or data labels. For working in Pandas, you have to import both NumPy and Pandas library to the Python environment using the import statement. Okay, import Pandas as PD and import NumPy as NP. But NumPy module, it's not mandatory one to import in every program, but if you are using the statements or the arrays, you have to import the NumPy library. Now we'll just see the working of the series, more into series or the practical part in the Spider environment. I'm using the Spider environment. Okay. So first statement is like, first we will just see how to create an empty series. For creating a Python series, Pandas series, what we have to do is you have to use the function pandas.series. creating an empty series. So first one is to import the library, import pandas as PD. Now what we have to do, you have to create a variable series s equal to pd dot series, and we're going to create an empty series, so no value you are passing. And when we are asking to print s, you can see an empty series is created. You can see an empty list, empty series is written, and the default data type of this series is float 64. Instead of PD, you can also use, instead of PD, what you can also use pandas dot. If you're not using the alias name, what you have to use, you can use pandas.series, no problem. You're getting the same output. It will return an empty series. But I'm going with that alias name. Okay, no issue. Then also you're getting the same output. Okay. Now, so this is how we are going to create an empty series. So for creating a series, what is the function? pd.series, pd is the alias name, or pandas.series, and by default the data type of series is float 64. Now we will just see how can we create non-empty series. Okay, we have seen, first we have seen how can we create empty series. Now we will see how can we create non-empty series object. Okay. Okay, you can create a non-empty series object. You need to specify the arguments for the data and indexes as per the following syntax. Okay, so this is the syntax. I'm just putting the command and giving, so that what is the syntax? That is series object. Any value, valid identifier name, you can use it. Series object is equal to, you can give like pd dot series. Okay, pd dot series, and you will be passing the data. Okay, and we will be passing the index equal to, okay, what is the value. So this is the syntax for creating the non-empty series. You will be passing the data as well as the index. Okay, so we will see one by one. First one is like specifying the data as Python sequence. Okay, here data means you can have a Python sequence, you can have an AND array, it can be a Python dictionary or a scalar value. So data, what all are the types of data that you can create a series? A Python sequence, an n-dimensional array, a Python dictionary, or a scalar value. All these types of data can be used for creating the series object. Okay, so we will just see first one with the data as Python sequence. Okay, so this one I'm just going to comment it. This is multi-line commenting. I'm just doing the commenting, and hash is standing for the single line comment. Now I'm just specifying, that is simplest way to create an object of series data type is using the sequence, any Python sequence, simply using any function. For example, I'm just importing the library, import pandas as PD. Okay, then I'm just creating a series s equal to pd.series. I'm passing a value, okay, range. range of 5. So range of 5 means what? Range function will be taking the values what? From 0 to 4. Range will take the value starting from 0. When 5 means what? It will take only like int minus 1, 5 minus 1, 4. So when I ask to print this one, I'm only passing the data over here. Index is not passed out. You can see index is not there. I'm only passed the data. Okay, so what it will be printing? So this is the data. In the right side it will be the data, and the left part it will be the indexes. Since I didn't pass any indexes, by default the index will start from 0, and it will be how many indexes will be there? It will be equal to the number of elements, number of data index. How many datas are there? It's equivalent to that same number of indexes will be available. Okay, range function, range of 5 means what? I told you it will start from 0 till 5 minus 1, 4. And since the index is not given, what happened? It is starting. What happened here? Index by default started from 0. Instead of that, if I have created like another way, another value like S2 equal to pd.series, you can give any way pd.series of as another list. I'm giving like 3.5 comma 5 point and 6.5 comma 8 point. Okay, and I'm just printing S2, print S2. You can see another series is created, and this will be the data. And by default, I didn't give the index argument. So what is that default argument? Index started from 0. Okay, you can see here it is int64 because the data mine is of integer type. That's why integer data type is int64. Here the data type, here I'm passing the floating point value as the data. So the data type of this series object is what? Float 64. I'll just give a hyphen so that it will be easy for you to identify. So hyphen into 20. Okay, it will be separated. You know that hyphen is a string, and you know that into 20 means into number, it will act as a replication operator. So hyphen will be repeated 20 times. That's how you got the line. Okay, that's a property of a string operator, replication operator in a string. This is a string into a number. It will be replicated. This string will be replicated n times. Now, if the user want to specify the index, what he or she has to do? You have to specify the index. So how we will be giving? So same data S3 equal to, I'm creating another series, pd.series. Okay, data I can pass it as a list like 10, 20, 30, 40. Okay, and I have to pass it as like index equal to what is the value, what is the index you need, you can specify. Okay, A, B, C, comma D. But while you are passing the indexes, make sure that you are passing the same number of indexes equivalent to the number of items, or how it should be. Indexes as well as the data should be the same number. Otherwise, it will result in an error. We show you that one. Also, S3, if I just print S3, what is the output you are getting? Instead of, since I am passing the indexes like A, B, C, D, what happened? It's replaced, the indexes are replaced by A, B, C, D, and the data is like 10, 20, 30, 40. The data is of int64. Now, suppose I'm passing an index. I'm passing an index like E. I'm passing E. That is 5 indexes, and I'm having how many data? 4 elements in the data part. Okay, and I have 5 elements in the index part. And when I'm running this program, you can see a value error. Okay, so this type of question also may come if the value of the indexes and the value of the data is not matching. What type of error will come? It will result in a value error. Okay, if the values are mismatching, it will result in a value error. Similar way, here I am passing 3 and here I am passing the 50 as the data. So what it will result? Again, it will result in a value error. Here data is 5 items are there in the data and index I am passing 4 elements. Again, it will result in a value error. So make sure that if you are passing the 5 elements, the indexes, if you are specifically telling or you are user want the specific indexes, you have to give the exact number of indexes similar to the data. So here 5 elements in the data means you have to give 5 indexes. Otherwise, it will result in what type of error? Value error. Okay, so now I have given correctly, that is 5 data, 5 indexes. We got the output properly. So we have seen how to create an series with the sequence. Now we are going to see creating a series data we are making as an empty array. If the data is empty array, if data is empty array, what you have to do? You have to import what? You have to import the NumPy module to your program. For example, import NumPy as Pandas as PD should be there. It's already defined. That's why I didn't define. Even if you write it over here, also no issue. But otherwise, even if you didn't write, since I haven't commented, that will be coming over here. But I will be writing this way. Here also I'll write it so that it will be clear for you what all things are needed. So if the data you want to make it, if the data is an empty array, you have to import a NumPy module also along with the Pandas library. Okay, so I'm going to create another element like S4 is equal to, before that we want to create an array, isn't it? So I'm just creating an array, that is A is equal to np dot. For creating an array, we are having a function a range, isn't it? A range is there. Okay, a range function similar to the range function, and we are passing, giving the values starting from 3. Okay, start value, end value, and what is the step difference also you are telling. Okay, so an array is created. Okay, and you are passing, if I am passing or I'm printing this array, what will happen? You can see if I'm printing that array, you will be getting an array. This is the form of array. Okay, 3. Okay, 3 is the starting value, 13 is the end value. 13 means you can take only till 12. 3.5 is the step value. So 3 is printed because it's a floating point number. Array means you can have only homogeneous type of elements. That means all the elements should be of same type. Okay, so 3 means you cannot give simply 1 3 in integer 1. It also will become floating point 1. So 3 plus 3.5 is 6.5. 6.5 plus 3.5 is 10. 10 plus 3.5 is 13.5. That will limit, that cannot be over. We can only possible till 12. So these are the 3 elements in the array. Now this array element we are passing to make the series object. So how we will do? So I am creating like S4 equal to pd dot series, and what is the value you are passing as the data, this array, what we got it. Then I'm just giving like print S4. You can see print S4, what is happening? This 3.0, 6.5, 10.0, that become the data to the series. And since the index is not specified, default index started from 0. And what is the data type? Float 64. This is how you are creating an array, empty array. When you are using the NumPy array, you have to import this NumPy module also. Now, if the data is used as a dictionary, What do you mean by dictionary? Dictionary means the value will be enclosed inside a curly braces and the items will be in the form of key colon value pairs, and items will be each item will be in the form of key colon value pairs, and different items will be separated with commas, and it will be enclosed inside the curly braces. So for example, for a dictionary is like I'm just telling this is a dictionary example, that is 1 colon 10 comma 2 colon 20 and 3 colon 30. So anyone, this is in the item, this is one item. First one is the key and this is value. This is another item. Key, it will be in the form of key colon value pairs separated by commas, and it will be enclosed inside the curly braces. This is a dictionary. Okay. So we will just see how can we insert these, means how can we use this dictionary as the data to the series. Okay. So we are going to create another object like s5 equal to pd.series. Okay. And I'm just calling a dictionary like a Jan, how, then colon, I'm giving 31, Feb, I'm having 28 days, and March I'm having 31 days. Okay, and I'm just using the April also, it is 30 days. Okay, so this is the dictionary, and when I'm passing here print s5, okay, print s5, I'm running the program. You can see you will get another series s5. You can see over here. This is the dictionary I told you. It will be enclosed inside the curly braces. It will be in the form of key colon value pair. When we are using dictionary as the data, what will happen? The keys will come as the indexes of the particular series object, and the values will come as the data. Okay. Key will become the indexes and value will become the data of the series object. And here, what is the data type? That is data type of the data object, that is in 64. So while using data as a dictionary, key will be the indexes and value will be the data to the series object. Kindly note that one. Now, data as a scalar value. Scalar value means what? Constant values in its scalar value. Okay, data as a scalar value. So for creating a series, what is that? What all things it is possible? For creating a series data can be of a Python sequence, it can be of an empty array, it can be of a dictionary, or it can be of a scalar value. Okay, so how can we create a scalar value? Means it's a single value. Okay, data will be of a single value. But when we are using the scalar value, just keep it in mind that index should be provided. Okay, here and all index is not a mandatory one, but if you are using a scalar value, the index must be provided. And you can have more than one, there can be one or more entries in the index sequence, and the scalar value will be repeated to match the length of the index. For example, if I have given like S6 equal to pd.series, okay, I'm just telling like a 10, okay, as my value, and I'm giving index equal to, okay, index equal to range of 0 or 0, 1. Okay, starting value is 0 and the end value is 1, means what? Only 0 will be counted. So when I'm just printing, print S6, so you can see what is that? You are having only one item, isn't it? Range function is having only one value. Okay, one index only in the range function. So that time only one time only the scalar data is repeated. Suppose if my value is like this way, I'm giving like 0 to 5. How many times it will be repeated? You will be having that till this many times 0, 1, 2, 3, 4, that many times how many indexes are there till the matching indexes the data will be repeated. You can see the scalar value will be repeated to match the length of the indexes. Okay. So if you are giving so, the scalar value will be repeated to match the length of the indexes. So index you have to give it. It's a mandatory one where you are specifying data as a scalar value. So we have seen how can we create an empty series. Also, we have seen how to create a non-empty series. Non-empty series data can be of Python sequence, it can be of empty array, it can be of a dictionary, or it can be of a scalar value. While creating the scalar value, the point to be noted is that the index should be provided and the scalar value will be repeating exactly to match the length of the indexes. Okay. Now we are going to see that in the series object, how can we add a nan value? Adding nan values in a series object. What do you mean by nan? Nan stands for not a number. Not a number. Okay, it is the legal empty value for filling the missing data. Legal empty value for filling the missing data, to fill the missing data. It's a part of NumPy module. NumPy module, and the data type is the type of nan is what? Float 64. So these points you have to keep it in mind. So I'm just going to create this series object by the nan value. So how can we create? I told you it's a part of NumPy module, so you have to import the NumPy array. NumPy module already in my program I have like 2 pandas and NumPy is already imported. That's why I'm not writing the syntax again. So I'm just going to create pd.series. Okay, and I'm giving the data like a 6, np. Since it's a part of NumPy module, you have to give like np.nan. Okay, and I'm giving like a 10. Okay, so you can see that this is an integer. I have given the second value as a missing data, I don't know. 10 I have given as an integer. So when I ask to print this one, so obviously you will think that the data type of this series S7 will be in 64, isn't it? Because I have given the integer data. But you can see over here, and I'm printing this series S1, automatically the other elements are converted into float 64. Why? Because nan is float 64. The data type of nan is float 64. And in a series, you can have only homogeneous data. That means all the elements should be of same data type. So 1 is nan, automatically all the other integers converted into float 64. That's why 6.0. Kindly note this point. When we are using nan, the other values automatically will be in the floating point value, and the default data type of the entire series object will be of float 64. Suppose I can also create a series like this way. I'm just creating another series like S8. Just note down. pd.series. Okay. Range function I'm calling, and one starting from 1 till 15 means till 14 with a step value difference of 3, and index I'm giving like index equal to, and it's giving us x4 like a x4 x in a b c d e. Okay, and print s8. You will get the answer. Okay, what is that index? You can give like this way also as a for loop. Okay, so x first, this is a for loop, you can see for loop, and this is the membership operator. First x will take the value a, isn't it, and that x will be given as the index for the first value a. Okay, we know that the range function like you're starting from 1 with a step difference of 3. So 1, then after that next value will be 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13, 13 plus 3, 16, but that is not possible. So till there the data. So here this is the first for loop will be evaluated. You can see x will take up the value a, that will be given to this x, and that will be for the first index. Similar way for the second value, b will be given, c will be given, like that way it will be going on. That is how you can use the series. Okay, this is also possible to create the series and index. Also, you can also specify the data type of your data. For example, I have like a month is my data. What are the data? List I can give like Jan. Okay, this way also you can specify the Jan, then Feb as an array, or a list of item you can pass it. Then March, okay, and April, okay, fine. And after that, what will happen? I'm just giving days, okay, days equal to 31, then 28, then 31, 30, okay. So I'm just creating a series S9. S9 equal to pd.series. Okay, data I'm passing. Data I needed as the days, okay. Data is equal to days, okay, comma, index equal to the month, okay. Yeah, when we are passing the variables, you don't have the quotation marks. When I'm printing S9, you can get the same output. You can see data will be the days and month, index will come as the month. It's not necessary this data keyword is required. Even if you didn't give the data keyword, you will get the correct output. But you can see that, but you have to specify the index. But suppose if you are not giving the index, what will happen? If I am not giving the index, okay, if I am not giving the index, what will happen? We'll just check out. Okay, is it possible? You will not get an array because the whatever be the coming as the first one. If I give in the reverse way, first I give like month, comma, days. So here what will happen? The Python means here the interpreter will not know that if you are not specifying the index keyword, whatever be the value coming will be taken as the data, and the second one will be considered as the index. Okay, so make sure that you have specified the index keyword. If the index keyword is specified, so that the Python interpreter will know that it's the index. See, this is an error. Why this was error came? Because of the positional argument follows the keyword argument. So if this is the position argument, you have to specify Okay, this is the keyword argument. It has to be followed by this one. You cannot give in the reverse order when you are specifying the index keyword. Index keyword, if you are specifying, it should be coming in the second place. Okay. Otherwise, what is that? It will result in a syntax error. Okay. You can see it resulted in a syntax error. Why? When I'm placing this one, this is the position argument and this is the keyword argument. That should follow. Position argument should follow the keyword argument. That's the syntax error. So just order also very much needed. Okay. Kindly note that also. Now, so hope this is clear. Till now it is clear. Now we can also use mathematical function or expression to create a data array in series object. That is also possible. You can also specify the data type of the thing you needed. Suppose here, no, I'm just specifying that days comma index equal to month. And if I'm just telling that here, when I'm printing like this way, what is happening over here? You are getting us int 64. Suppose if I am specifying like my D type, instead of int64, I need my data type as, what is that? I need it as like float 64. How to specify like this way? np.float 64. Okay. So what is the data type specifying? That way your output will come. Okay. So for the series object, what all things are there? Data, then the index and the D type. These are the three arguments of the series function. That is the data, then the index and the D type. D type you can specify, but D type when you are specifying, it's a part of the NumPy module. Okay. Now we will just see how can we use the expression. Okay. How can you use the mathematical function or expression? Example, P is equal to np dot a range, okay, 9 comma 13. Okay. Now S10 equal to pd dot series. I'm passing this like what is that? Data is equal to a into 2. Sorry, a no, b into 2. B is the variable and index equal to print S10. So what is happening over here? When we are asking to print B, we'll be getting that array is printed. This is the array n 9, 10, 11, 12. These are the values printed. And what is happening? Data is equal to B into 2. B means what? First one is each item. You know that when we are using each item 9 into 2, what is the data? 18, 10 into 2, 20, 11 into 2, 22, 12 into 2, 24. Hence you got the data. Okay. So here if you give like this way, is it result in an error? Because both are data keyword as well as the index keyword we are using, whether it will result in an error? No. Okay, if you are using the keyword data, the order is not a problem. But if you are not using the keyword data, first it should be the data. After that, index you have to specify. If both the keywords you are using index as well as the data, the order, you can give index as the first argument and the data equal to what is the value, you can give it as the second argument. No issue. Suppose this is like an array. Suppose if I am using a what will I say? Suppose if I'm using a list instead of an array. Okay, how we are doing the mathematical expression. Suppose we say that C or LST list I'm using like a 9, same value I'll use 9, 10, 11, 12. Okay, when I'm using as a list, I'm using as a list when I'm using what S11, I'm creating a series object pd.series. Okay, after that what will happen, I'm just giving like data is equal to list into 2. Okay, list into 2. Okay, now I'm printing S11. What will happen? Whether it will multiply? No. When we are using the array, NumPy array, what will happen? Each element will be multiplied, isn't it? Vectorized operation is happening. Vectorized operation means when you are doing any operation, it will be applicable to each element in the particular array or the series object, isn't it? 9 into 2, 10 into 2, 11 into 2, 12 into 2. But when we are using the list, what will happen? Into operator will act as the replication operator. You can see that list will be repeated 2 times. You can see this is 9, 10, 11, 12, 9, 10, 11, 12. Index will be equivalent to the number of elements. Index will be repeated till the number of elements. You know that list, when you are using it, will act as a replication operator. But when we are using the list, if I have given like a list plus 2, whether it will be okay? It will result in an error. Because why? Because you cannot do an addition. List can only be added to a list. Then the concatenation will happen, isn't it? Isn't it? Otherwise, list cannot be added with an integer. List cannot be added with an integer. You know that list can only concatenated to a list. But so that's an error, will come type error. But if I have given like b plus 2, whether it will be an error? No. Why? It will be added. 9 plus 2, 11, 10 plus 2, 12, 11 plus 2, 13. Because when we are using with the series object, vectorized operation happens. That means when you are applying any arithmetical operation, it is applicable to each and every element in that particular series object. But even if the array, NumPy array also no issue. Okay, but if you are using the list, only that this is list can be multiplied only with list. List can be multiplied only with a number. And the list can be added only with a list. Suppose I have given like a list plus list. Is there anything happen? Error will not come. You can see list plus list means it's a concatenation. List is added to the next. For second list will be concatenated after the first list. Okay. So these are the things you have to keep it in mind. Okay, fine. Now we will move on to the series data objects. Not series objects, series attributes. Series object attributes. First attribute. When I say attribute means you are telling attribute doesn't have any brackets. Okay, whenever function is having these brackets, but attribute will not have the bracket, and the syntax for the attribute is what? Series object dot attribute name. Okay, dot attribute. That's the syntax. Okay, this is the syntax. Now we will just see which are the various attributes of the series object. First attribute is index. Okay, first one is index, series dot index. All and small case letter. Okay, what does it do? It will return the indexes of the series object. So we will just take out any of the series object. We have created many series object. So I just take out that S9. Okay, so print S1 S9 dot index. Okay, so when I give so, what will happen? You can see indexes of that S9 will be displayed. Okay, if I have given like a print S10, okay, S10 dot index. What is the index of S10? That will be printed. Okay, what is the index of S10? You can see index of S10 is what? This is S10, no? So what is the index of S10? 9, 10, 11, 12. Okay, suppose when I'm using, while using the index attribute, if I'm using like this way, what it will do? It will result in an error. So just keep it in mind, attribute doesn't have this bracket, okay? Attribute doesn't have this bracket. Now, this is the first attribute, that is index. Now moving to the next attribute, that is values, that is series dot values. Okay, series dot values. So how we will be using series dot values will be returning the series as an empty array. Okay, so for example, if I have used like print, same thing, it's we will use S9 dot values. Okay, values. Okay, so what is the output? You can see what are the values of that particular value, particular thing. You can see what is the value of that S9. S9 is a float 64. And what are the values over there? You can see this is the S9, no, 31, 28, 31. So it's a floating point value. So 31 point, 28 point. In the array, that 0 will not be displayed, and array the items are not separated by the commas. It will be returning the value in the form of an empty array. Next one, D type, series dot D type. What it will do? It will return the D type of that particular series object. So print I give S9 dot D type. What it will return? You can see the D type is float 64. Isn't it? Because you got the this one as this way. If I have given like print S10 dot D type, what will be the output? I just run it. You can see it is of int32. Where is that? Int32. S10 is int32. You can see this is int32. That is a D type. So D type part, it will return the data type of that particular series object. Now we will just say the another one, shape. Shape means what? Shape will return the shape of the particular series object that will be returning in the form of a tuple. So you can see when I say print S9 dot shape, okay, what will happen? This is a tuple. You will be getting the output in the form of a tuple. That means series is having, it's a one-dimensional array. Either it can be having x-axis or the y-axis, isn't it? So here it is like a tuple that is standing for the x-axis. That is 4 elements are there. 1, 2, 3, 4, 4 comma, and there in that there is no y-axis, so it will be giving an empty, but it will be returning in the form of a tuple. Note down, shape attribute will return the value in the form of a row, column, pair in the form of a tuple. Since the series doesn't have that the second element, so it will be leaving as empty one, but it will be returning in the form of a tuple only. Next one, n bytes. So n bytes will return the number of bytes in the underlying data. 4 elements are there, isn't it? 4 elements are there in S9. Float 64. 1 byte is equal to how much? 8. One element is 8 byte. Float 64 means one element 8 byte. 8 into 4, 32. So n byte will return the number of bytes in the underlying data. Okay. And another one is ending. Ending stands for the number of dimension. Print ending. So S9 dot ending. It's a series object. Always the dimension will be 1. Okay. Any series object you just take out. Print S2 dot ending. Series means it's one dimension. So always the dimension will be 1. Any that you have to keep it in mind. Series, the dimension ending will be 1. Why? Because it's a one dimensional data. So if I give like S5 dot ending, all will be the 1 will be the output. And dim always 1 for the series object. And dim means number of dimension, number of axis, only one axis, no one dimension. Now another one is size attribute. Size will return the number of elements in that particular series. Print S9 dot size. Size means how many elements are there? 4 elements are there. 4 elements. You can see 1, 2, 3, 4. 4 elements it will be returning. Number of elements. Size attribute will return the number of elements. Print S10 dot size. What is the size? You can see 4 elements. If I have given S11, how much elements are there? 8 elements are there. You can see S11 is having 8 elements. 1, 2, 3, 4, 5, 6, 7, 8 elements. So size attribute will return the number of elements. Next one is item size. Item size actually it's not in the latest version is not there. That's why it's removed. Will be removed in the future version. When we are running once again, we'll just check out what is the item size that is not showing the output. So that's because in that they are updating. That's why this item size, the output you are not seeing. Okay. But what is item size? It will return the size of the data type of the item of the underlying data. Okay. What is the item data type item size? Okay. Size of the data type of the item of the underlying data. But that is not in the latest version. So, okay. Now, has-nans will check whether it will return true if your series object is having a nan value. If it is not there, it will return a false. Okay. So S9 dot has-nans. Okay. If I give one light, it will return false because that is having a data. I just comment on this one. Okay. Why false? You can see why false is there. Because there is no nan value. Here you can see S9, there is no nan value. So it is returning false. There is one item I have given a nan value. No? So I'll just check out that one. Where is that? S7. Okay. S7 dot has-nans. Okay. You can see it will be returning true because that contain a nan value. Has-nans will return true if that particular series object contain a nan value. Otherwise, it will return a false. One thing, no, here I will tell you in the future version, this item size will be removed. But here you can see the size is there, 8 is there. We know that the float 64, one item is of 8 bytes. That's the 8 you are getting. Okay, 8 bytes. But in the future version, this you cannot see this one. Okay. So to remove that warning, the site commented it. Okay. Now we have seen one more attribute is there, empty. Empty will return true if the series is empty. Otherwise, it will return false. Okay, so S9 dot has so empty. Is this empty? No, it contains some data, no? So it will return false. But you can see that I have created a series, no? What is that empty series? What is that empty series name? I will just remove the comment, no? S is the empty series, no? So if I just give like that way, print s dot empty, you can see what is coming. It will return. Is it s empty? Just checking. One second, I'll just create a series. S12 equal to pd dot series. Okay, I'll just write like it is an empty series. When I'm giving s12 dot empty, you can see it will return true. Okay, it is returning true because it's an empty series. You can see when I print s12 is an empty series. So it returned the value as true. So empty attribute will return true if the series is empty, otherwise it will return false. So these are the series object attribute. Okay, so different series object attribute we have seen, index, values, then d type, shape, n bytes, endim, size, item size, hash names, and empty. So hope this is clear for you, how we have created the series object, how we have created access this one, how to use the series object attributes also.